Welcome everyone. In this video lecture, we will solve a problem based on the MOSFET circuit at DC. So in the last video, I have also covered a similar kind of problem on this one. So the circuit will be same. Okay, so the circuit is given. In this circuit, we have to design the circuit parameters. Means basically we have to find W by L ratio and R, and the given things are mu n COX value is given, Vt is given, threshold voltage, the drain current ID is given 160 microampere, and Vd is 1 volt is given. So we have to find the value of W by L and R. So this one is the gate in of that NMOS, and this one is the drain in, and this one is the source in. So here we can easily say the gate and drain are sorted. So here the gate and drain are sorted, means they have the same potential. Okay, and so if gate and drain are sorted, it will be in the saturation region always. We have also discussed in the last video. So once again I am just showing some concept. Okay, means if this one is the ID VDS curve. Okay, this side will be in the saturation region, and this side will be in the linear region. Okay, up to this. Okay, so for the saturation region, the VDS should be greater than equals to VGS minus VT for the saturation region. This one is the basic concept, but every time I am just noting down this one, and VDS will be less than VGS minus VT, then it should be in the linear region. Okay, so now we can easily say the value of VD and VG is same, that is our 1 volt. So VDS, I am just writing VGS minus VT. Okay, this will be always greater. Why? Because VD minus VS, and here we can write VG minus VS minus VT. So here also we can say the Vs is a ground potential, so 0 volt. So these two will be 0. So Vd will be greater than Vg minus Vt. So Vd is 1 volt. Okay, so make it 1 volt. 1 volt minus 0.6 volt. Okay, so 1 volt will be always greater than 0.4 volt. So we can easily say this condition is okay. So when gate and drain is sorted, okay, it is always in the saturation region. So that we have to remember, or you just do practice like this, and gate and drain are sorted. So this is in the saturation region. Okay, so like that we can prove also. So this one is the saturation region. So we have to apply the drain current equation in the saturation region. So from there we can find the value of W by L. So what I am doing here, I am writing ID equals to mu n COX by 2 W by L VGS minus VT whole square. The saturation current equation, drain current in saturation region, like this. So ID is already given 160, better to write 160 micro. Okay, I'm writing micro. Okay, then mu n COX is given 200 micro. No need to write ampere voltage. Unit will be cancelled out. So micro mu n COX. Okay, by 2 W by L we have to find. So just like W by, now VGS. So VG is same as that of VD. So 1 volt. So VGS is VG minus VS. So VG is simply our 1 volt. 1 volt, and Vs is 0 volt. So it should be always 1 volt. So VGS is also plus or minus 1 volt. So one can write 1 minus 0.64. whole square. Okay. Now this micro we can easily cancel out. This 2 and this would be 100. So okay, one more line, right? 160 to 100 W by L, and this would be 0.4 whole square. So once again we have to do a step by step. 100 W by L, because you have to find, then one can write 0.4 into 0.4, and if we remove this decimal then it should be 100, so this should be cancel out. So one can write 160 by 16 equals to W by L, so it should be 10. So the W by L value will be 10. Okay, so this one is the W by L value for this question. Okay, now we have to find this R value. So what I am doing, I am just making this R. This one is 3 volt, that is our VDD. Make it 3 volt, and VD is also given 1 volt. R we have to find, and ID is also given. So simple Ohm's law, we can write VDD minus VD by ID. Simple calculation is there, VDD minus VD by RD. So this R value will be, VDD is 3 volt, 3 minus 1 divided by ID is 160 microampere. Okay, so we make it 160 into 10 to power minus 6. So it should be 2 by 160 into 10 to power 6, or one can also write like this, 1000 into 10 to power 3, because most of the time we have to write in kilo. So like that you can write, okay, 2 8, so 100 by 8, so it should be, or like that, into 10 power 3 also, right? So 100 by 8, so 100 by 8 is nothing but simply 12.5, and this one is kilo, so kilo ohm. So the R value will be 12.5 kilo ohm. So like that we can design the value of R. Okay, means what should be the R value? 12.5 for 160 microampere current with VDD 3 volt and VD 1 volt. Okay, we have used this concept, like, also once again I am repeating, this one is R. Okay, some potential like V1 and V2, and some current is flowing I. So this I will be V1 minus V2 by R. So R equals to this. Okay, so the R value is okay. Now W by L we can easily find by using the drain current equation in the saturation region. So we have first identify in which region the circuit is operating, where gate and drain are sorted. So it is obviously in the saturation region. So after making all the calculation, we can find the value of W by L and R. So the final answer for this one will be, okay, I'm writing W by L will be 10. This will be 10. Okay, no unit, and this R will be 12.5 kilo ohm. So this one is the answer for this one, and this one is the exercise problem of an of a microcontroller circuit by Cedar Smith book. Okay, so thank you for watching this video.